Hi everyone, this is Victor with Lighting Up Paxton again. I've had some problems recently with triacs going bad on my light controllers. So for all the other Christmas enthusiasts out there that do animated displays, I figured I'd show how I go about replacing a triac. Light-O-Rama will usually fix them if you send their boards back to them, but why wait for all the shipping and the extra time when you're down a controller, or in this case, four, because I actually have four controllers that happen to have bad triacs right now. You can actually do this yourself if you do just some minor soldering skills. So I'll show you how to go about that in this video. Now this is really detailed, small, finite process involved, so I'm probably not going to be able to show you every single little thing on the camera, but I'll show you step by step what I've done, because it's really going to be hard to get a picture of some of the small minute things in here. So you see, this is just a PC controller I bought back in 2011. This is actually, I believe, the first Generation 3 PC controller, and from what I understand, some of these batches had bad triacs in the first round of the Gen 3s, and lucky for me, I've got like 8 bad triacs here. So this is my last 2 triacs I'm replacing. This board has 2 bad triacs. You can see here's my channel list here, and I got one on channel 4 and one on channel 15. So unfortunately, I got to take off both heat sinks on this one. We'll go about doing that. Supplies you'll need: I got my controller here. I pulled it out of the display. I just unplugged everything so I can bring it here in the shop. Tools: we got wire cutters, angled wire cutters, large Phillips and a small Phillips screwdriver, pair of pliers, pair of needle nose pliers, pair of vice grips, just a small vice grips. You don't need anything really big, or some people even use surgical hemostats. You'll see what we'll use that for later. Spare solder, you can buy usually your local hardware store, Radio Shack. Toothpicks, you'll figure out why later. Spare triacs, I bought these from Mouser. I don't bother getting them from LOR anymore because they only want to send you a few at a time. But they're really cheap. They're only like $1 a piece. So I got a few of them there. And then I can't remember what this stuff is called, but I saved a bunch of these when I was soldering my own boards. It's the little heat transfer cream that you put on the triacs when you put the heat sinks on. If I can remember the name of it, I'll post it on the video. And then soldering irons. I've got a 25 watt and a 40 watt. These are in really bad shape. Usually you probably want your tips to be a little better than that, but I've had these for a few years and they're still working out for me, so I probably need to get new tips for them. So you can buy these at hardware store might have them. I bought these at Radio Shack too. So there's your list. Oh, this thing, I don't really use this thing, but some people have these. It's like a little tiny turkey baster. It's for sucking out solder. It's got a little tip there, and you can suck solder out with it to heat it up. I don't really use this thing. It doesn't really come in handy very much. So that's the list of all the stuff we need, and I'll go ahead and get ready, and we'll go through the steps. Okay, one thing I should probably mention before we get started is, why do triacs go bad, and what do they do, and how do you know if you have a bad triac? The number one cause, or number one way to tell if you have a bad triac, is if you have a channel that's stuck on at about a 50% intensity, something like that. And that's how I find them right away. And you can do other things. There's if you go on some of the forums, there's diagnostic stuff you can do to figure out if you have a bad triac. Anymore, if I have a channel stuck on 50%, I don't even bother doing all diagnostic stuff. It's just a triac. I know how to replace them. Under an hour I can usually get one done. But so that's how you find out if you have bad triac. If you have a channel stuck on 50%, it won't go off. Even if you go through hard utility, tell everything turn off, it still stays on. It's definitely a bad triac. Well, likely a bad triac, I guess just to say. So that's how I marked these here. I had items that were only on 50%, weren't going off. So the triacs here are these little things here attached to the heatsink. Now they do all the voltage regulation, causing the lights to dim. And I'll put a link to a Light-O-Rama forum that explains about how they work. But it's really really neat. And the way when they go bad, there's a way that they go bad where they just happen to lock on 50% intensity. So that's what we're doing. So the first thing I'm going to do to replace this one bad triac, got one on each side. So this is channels 1 through 8 and then 9 through 16. Most people are probably very familiar with these boards. First thing I got to do is I'm going to go ahead. If we only had one side where the triac was bad, all we have to do is undo these wires here. But since I have both sides I have to work on, I'll go ahead and undo both sides. All we're going to do is first we're going to pull out all the black wires here on whichever sides are affected. We don't have to touch the white ones, the neutrals. You'll see why in a minute. And then after I undo the black wires, I'm going to start undoing these screws right here. I find it's easy to do this. Easiest to do this with the board still attached into the box because the board's not moving around on you and it stays secure. So we're going to undo all of the black wires, just pull them off the clamps here. And then we're going to undo all the screws. We have to undo every single screw on this side in order to get one triac out, which is very fun. Now these are very stubborn sometimes. We got these lock washers on the back. So this is where we use the needle nose pliers. My little needle nose pliers here. Usually what I'll do is I don't need to put the screwdriver on them yet. I'll just use the needle nose pliers to break them on this side, just to loosen them up a quarter turn. And then I'll use the screwdriver. This is the thick Phillips screwdriver, number two Phillips, to undo the screws on this side after we break them, the nuts on this side. And then sometimes, you probably need to be careful, but sometimes they even use the drill for it too, to undo it a little faster. So I'll go ahead and undo those and we'll get back to the video. Okay guys, I'm back. You can see what I've done. I've pulled out all of the little screws from between each one of the holes of the triacs there. You can see it really good there. And I pulled off all of the little hot terminal wires off the sockets there. And for that, those will get pretty stubborn. So for those, I use the tiny lineman's pliers for those. Just pull them right out with that. That worked really well. I just let all the nuts fall back behind the controller because we got pulled out anyway, so I really don't care about that. We'll get the nuts later. And you can see I had to do both sides, but if you only had one triac bad, you'd only have to do the one side where your triac was bad, but since I have one on both sides, I had to do both sides. And you see I left all the neutral wires intact. I just pulled all the blacks out, kind of pulled them out over here. Again, used the needle nose pliers first to break all the nuts a quarter turn, just turn them all quarter turn left. And then right after you do that, then it makes the screws a lot easier to unscrew. I did cheat and I did use the impact driver, but very carefully use the impact driver. It can be pretty tricky on a couple of these, getting around the transformer because the angle you have to work at. So be sure not to strip your screw. But again, number 2 Phillips is what you want to use on the triac screws. So I got all those done. So now what we're going to do is we got to pull the board off. So our triacs are not attached to the heat sinks anymore, but the heat sinks are still attached to the controller board. And then the heat sinks are screwed into the enclosure. So we're going to undo this screw, and then back in here, there's a screw down in here, and another screw down in here. So there's 4 screws that mount the heat sinks to the plastic enclosure. We're going to undo those first, and then I'll get back to you. We're going to undo the screws, and we're going to pull the whole thing back towards us. Okay, I undid those 4 screws there that held on the controller heat sinks. So now the whole thing is loose, and the only screws now that are holding the control board to the heat sinks are these screws here with the little studs in the middle there. So you can see all the studs that connect the heat sinks to the control board. So rather than try and wrestle with the screws on the front of the board, we can damage something. The best way I like to do this is, now that we're loose but the wires are still attached at the bottom, we're just going to flip the whole thing over. And we're going to undo. Now we only have to do the side where we have bad triacs, but in my case I'm going to do both sides because I have triac on both sides, both one of the sides. So we're going to undo these screws here. Right there and then right there. So we got 8 screws, and we're going to undo those for both the heat sinks, so that way we can get access to the solder side of the board. So we have our screws out of the triacs already. Have those all out. We pulled the board off the enclosure, so now we're going to attack these screws. And these screws, I believe a number 1 Phillips works best on these. So I'm going to pull those off, and then we'll get back to it. Okay, I pulled the heat sinks off now. You can see they're sitting right there. I went ahead and put all the screws with them. So these are the screws in here for the triacs, and these are all the mounting screws that we pulled off. So we want to keep those separate. They look different, but I like to keep them organized. So those are there. Here is our PC board now. So we have heat sinks removed, and we have it pulled off of the enclosure. And now we can see here the back of the board. This is where all the soldering occurs. So you can see all of these soldering connections, and basically what happens is everything on this front of the board here has pins that go through holes in the board, and then when those pins come through on this side, they get soldered to the little metal plates on the back here. So now our triacs are all soldered along the edges. Let me get rid of the glare. So you can see here, now there's 4 soldering connections here. Let me see if I can get these pointed right. Okay, so you can see there's 1 connection here, 1 there, 1 here, and there's a 4th small one on the same little solder area right here. We're going to go after these 3 big ones right here. So on whatever bad triac you have, so you can see it says your channel numbers right here, 6, 5, 4, 3, 2, 1. You can see them all right there. Whichever bad triac you have, corresponding triac is right next to that. So on this one, I had one of them was triac number 4. So channel number 4 is right here. So I'm going to pull this triac out, which on this side is going to be the connections right here. So we're going to pull those, there you go, pull those out eventually. Now, the ways to pull a triac out, this is probably the most difficult part. Well, I guess depending upon how you do it. This is what some people use a hemostat for, or I have a little pair of vice grips, is that you can attach, get your board. This is why doing it this way is a little more difficult because we have all the wires still attached. But you pull your board off the edge of a table, attach a small vice grips, just some sort of weight like a hemostat people used to the triac, and then you have to try and heat up all 3 of these soldering connections at one time with your soldering iron over there. And then if all 3 get heated up and turn to liquid at the same time, then the triac will just drop out. That I've had really a lot of difficulties with that, because in my opinion it's really hard to heat up those 3 terminals all at once. So the way that I go about this is, again, I'll find my controller number 4. Let's see, channel number 4 right here, and I just, as bad as it looks, I just bend it back and forth until it breaks off. So there, I just broke off controller number 4. And now what I'm going to do, I have to get these soldering connections opened back up. So now I'm going to get my 40-watt soldering iron, the bigger one works well for this, flip this board over, and then I'm going to heat up each one of these connections one at a time. And I'll do that by, I'll stick my soldering iron right alongside, right up against the connection here, and allow it to heat up. And once it becomes liquid, on each, I'm going to use each one of the connections, I'm going to take my pliers. I'm not going to put my pliers on it while I heat it up, because the pliers will act like a big heat sink and not allow the solder to melt. So I'm going to hold them out away from the connection, use my 40-watt soldering iron to heat up each connection. Then as it turns to liquid, I'm going to immediately grab onto it with the pliers and pull straight out. And after a couple tries, each one of these should come out. And there's just enough room to usually grab onto these. If not on this side, this side is actually, the front side is probably the side I have most luck with this, because where I broke it off, there's some little nubs here. So maybe I'll heat on the front of the board and then pull it straight out. Either way, if that doesn't work, you can always just heat it up with your soldering iron, and this is where toothpicks come in handy, because the solder won't stick to the wood toothpick. Heat up liquid and then use a toothpick to push the remaining pin back through the hole. As you heat it up after it turns to liquid, you can do it that way too. And we'll also use the toothpick later to clean out the hole. So first I'm going to go ahead and get these pins out. I'm going to try and do it my usual way, with I heat it up and just pull out the pliers. If not, then I'll use a toothpick to push it through. But again, the other way is with the hemostat way, but for some reason, there must be a trick to it I haven't learned yet, but I cannot heat up all 3 holes at the same time, even trying 2 soldering irons at once. So we'll try, I'll go ahead and get this done, and then we'll come back after I got the holes cleaned out. Alright guys, I got the pins pulled out. The way I ended up working was I used the toothpick to heat up the back end of the board first, on the back side here. Heat it up with the soldering iron individually each hole. Use the toothpick to push it through the front. Once I got to the front, I had enough where I could use the pliers to grab onto each one of the little pins that were left as I heated them and just pulled it out. So Again, this is probably the most difficult part is this. And then now what we're going to need to do is we need to have lots of toothpicks, because I go through a lot of these because they start to bend and get frayed and stuff. But now what we're going to do is we're going to take our 40-watt soldering iron right here. You can see got the big tip on it. And we're going to heat up each one of these holes. Now we have the pins out, but you can see looks like only one of them has actual hole in it. So we need to clean out the rest of the solder so we can get the new pins of our triac to fit in there. And so what we're going to do is we're going to heat it up, and then when the solder turns to liquid, we're going to push our toothpick through as far as we can, and then pull it right out, back out immediately, so we don't want to get stuck. So we're just going to keep doing that. We're going to do it a couple times on each hole, and then after we get that done, we might even flip the board around the other way and clean them out from the back end too. But we want these holes as open as possible and cleaned out, because we need all the room we can get to get the new pins of the new triac in here. So that's what I'm going to go ahead and work on next. So again, heat up with the soldering iron. A 40 watt works best. It's got the best heat. And we're going to use the toothpicks. Again, you want a fresh tip on your toothpick. So if a tip gets bent, you have to get another toothpick. And we're just going to keep pushing it through the holes after we heat it up. And again, it only works if the solder's wet or melted. So we're going to have to keep heat on it. And then we need these holes as open as possible. So we're going to do that next, and then I'll get back to you. Alright, we have some cleaned out holes now. Hard to tell, but I reamed them out with a toothpick several times, and they are cleaned out now. And you can test that by, now these triacs fit in there pretty tight. You can test that by just starting to put your triac in, but don't push it in too far, because then it might get stuck and you may not get it out. But as long as you can get your pins to start to fit in there, you should be good to go. So now here we have this triac. You can see it comes with much longer pins than what are on the board, because they're made to be cut off. So what we're going to do is, you can see the thickness of the board is just about 1/8 of an inch maybe. So what we want to do is we want to take a look at our triac here, and you can see where the pin is wider. The wider part of the pins will be above the board, and the thinner part of the pin goes into the board and underneath. So we want to cut, before we put this in here, it's easiest we do before we put it in there, because it may not even slide in if we don't do this now. We want to cut these pins off so we have 1/8 of an inch between the from where the pin becomes narrower to where we cut it. Should be about 1/8 of an inch, but probably just a little bit thicker than this toothpick here. So we want to cut it right about there, say. So the idea is that when we stick this triac into the board, it just barely pokes through the other side, barely. We don't need much at all sticking to the back. So I'm going to go ahead and cut this pin, and then after we cut it to fit, you can always hold it up against the side of the board to make sure you have your length right. And then after we cut it, we're going to stick it in our holes. Now, they are pretty tight, especially on these PC boards. So we might have to wiggle it a little bit to get it in there. But, don't force it too hard, but it should go in if you wiggle it, left and right a little bit to get it to go in. And again, the top of the pin here, the wide part should be above the board. So we're only going to slide it in to where the pins there become narrower. And it should look right, because it should be even with all the other ones on the board too. So I'm going to do that next, and then we'll move on from there. Okay, you can see here I have my new triac in now, right here, and you can see the spacing is really good because I bottomed out the pin here where the thicker part rests against the top side of the board. And on the underside, you can see, since we cut it ahead of time, you see our new triac right there. Just barely, some of that's just some of the extra solder that we melted out of the way, but just barely poking through the board, hardly at all, almost. So now, as long as we have contact on the inside of those holes there, as long as those pins do make it through, then we should be good to go. So now what we're going to do is we're going to take our soldering iron again, and we're going to remelt the solder on each one of those 3 holes around the pin. So we're just going to hold our soldering iron right up against the hole there, and it'll melt the solder. And then what we can even do is, if we want to ensure we have good contacts, we might add just a small amount of a little bit more solder around them. And you'll know you have a good connection. You can compare it to the other factory connections on here too, how the solder just kind of pools up around the connections like that. And that's what we want to go for over here. So I'll go ahead and solder those up, and I'll show you what a finished solder joint looks like. Okay, here's our finished solder joint. It doesn't look like the factory one, but it doesn't have to. Probably because my pins don't poke through quite as far. But you can see I just kind of pooled the solder around each one of the pins. What we don't want a giant big ball of solder sitting above it, because then we know that the solder didn't penetrate down through the fitting on the board. So when it sinks into it a little bit, we know we have a connection. Very important here at this point as well to make sure your soldering connections are not joined at all by any extra solder you may have. So you can see the board just got a little bit of glazing on it from when I had heated it up, but there is no solder here bridging between the three connections. Very important, so we don't fry the board when we power this back up. So now that we have our connections made, it's at this point where I usually flip the board over, and I'll plug in the bad channel here. So if your plugs, make sure your plugs are numbered, of course. And so I number all the plugs. I think from the factory they might come numbered too. I really don't know because I've always made my own boards. But so we're going to plug channel 4 in along with another channel next to it that was not that did not have a problem. And we're just going to hook up to the hardware utility just like this. We have no heat sinks on it, so we don't want to put any big load on it. Usually I'll just use like a 50 count string of minis or something like that. Something like an incandescent, something that we know will fade well, but won't put too much load where it'll overheat the triac since there's no heat sinks attached to it. So we're going to go ahead and fire that up and then test it to make sure we have all the fading's right. So we compare the new triac we put into the old triac, see if the fading matches, if everything works correctly. If everything works correctly after we hook it up to the hardware utility, then we'll go through the reverse process of hooking everything back up. We'll take our 2 heat sinks, or in my case 2, because I still have to do this one on this side, I haven't done yet, but take our heat sinks, we'll flip the board over, we'll attach our heat sinks to the screw holes right here with the screws we had. After the heat sinks are attached, you can either put the bolts through the triacs at that point, or you can mount the heatsink into the enclosure, then put the bolts on later. Although if you do it that way, if you have a bolt that you actually drop, you got to pull the whole card out in order to get the bolt out of the enclosure. Also, at this point in time, I guess it's called thermal compound. This stuff that, I don't even know where you get this. I just have a lot of extra from when I was soldering my own boards a couple years ago. Before you put the heat sinks on, you do want to put just a small amount of thermal compound on each one of the triacs again, especially your new one. Actually, some of these, there really is a pretty good amount left on them, so you really don't need much. But make sure we definitely want to get our one that we replaced, just so we want as much heat transfer as possible from the triac to the heat sink, so we don't fry any more triacs. So we'll put that on as well, and then of course all the bolts, we'll pull them together. So you can see here on the heat sink, if I can get a good picture. Yeah, you can see where the old thermal compound was attached. It's not really a glue, it's just a compound that sticks to everything, that allows the heat to transfer easily from one component to another. So that's our finished board. So after that we get it all soldered up, and we already know we tested it, so it should be good to go, and we'll put it back into the display. So that's how you fix a triac, and any questions, be sure to leave a comment. Thanks.